R
Yes, sir.
Yes, sir.
R Dugar.
Yeah, yeah, yeah.
Okay.
So start பண்ணலாம் 6:33. Recording we can start.
Initiated, sir. Sir, shall I start, sir?
சொல்லலாம்.
Ah. Good evening and greetings to one and all present here for this webinar on lifelong career in data science, AI, and physical AI. Now I request Mr. T. Ramesh Dugar, President HCC, to welcome the gathering.
Thank you. Good evening, ladies and gentlemen. It's my pleasure to welcome Mr. S. Ramachandran, Practice Leader, Engineering and Manufacturing, HFS Research Bangalore, who has consented to address the participants. I welcome and thank Mr. H.R. Mohan, Chairman, Information Technology Committee of our Chamber, IEEE CS, Madras CSI Chennai, ACM Chennai, IEEE LMAG, and the members of all the associations. I thank IEEE CS Madras, CSI Chennai, ACM Chennai, and IEEE LMAG for joining with HCC for this webinar. A warm welcome to all the participants who have joined this webinar. In recent years, there have been talks on data science, AI, generative AI, physical AI, etc. Data science is an interdisciplinary academic field that uses statistics, scientific computing, scientific methods, processing, scientific visualization, algorithms, and systems to extract or extrapolate knowledge from potentially noisy structured or unstructured data. Since AI and its applications are widely used, the future is dependent on AI, and so are the careers also based on this. We have a wonderful speaker who is well versed with this topic, who will explain about AI and how the future jobs are centered around AI. On behalf of HCC, welcome the speakers and all the participants from the partner associations. Thank you.
Thank you, sir. Now I request Mr. H.R. Mohan, Chief.
Units IEEE Computer Society, CSI Chennai, ACM Chennai, IEEE meetings through the Google Meet, watching the YouTube streaming. In the recent past, particularly after the introduction of Gen AI by OpenAI. AI means generative AI. But today we are going to speak beyond generative AI, that is a physical AI, which has been in vogue for quite some time. But people are not fully aware of how this physical AI is changing the years to come, particularly in the areas of manufacturing to come, particularly in the areas of manufacturing, hospitality, and so many areas. Physical AI has got a lot of important role to play. And today's talk is going to be about the importance of data, talk about the importance of data, talk about the enterprise AI, and give an overview of physical AI. The last and give an overview of physical AI. The last part of the talk will be on the importance of lifelong learning for the students and professionals to plan a career in physical AI and evolving professionals to plan a career in physical AI and evolving variants. Particularly, the physical AI is gaining a lot of importance in the production related areas. There's a lot of right from the students to professionals as well as the faculty to do a lot of research in this area. So this talk will highlight all these potentials of the physical AI and of the physical AI. And let me formally introduce the speaker, Mr. Ramachandran, who is quite familiar to us. For several years, delivered webinars, workshops in both physical and online mode. Mr. Ramachandran is fondly called as Ram. He is a practice leader at Global Research and Advisory Firm HFS Research, specializing in engineering and manufacturing. Years of experience. He bridges deep expertise uh, at the intersection of core manufacturing and digital. Research topics include physical AI, software defined products, service as software, and Industry 5.0. Ram previously held roles in the thought leadership unit of Infosys, the Knowledge Institute. Prior to that, he was the principal research manager at the Asia Pacific Center at IDC and a Six Sigma Black Belt Genpact at enterprise organizations such as General Electric Energy Business, Hewlett Packard, leading product lifecycle manager as a cell leader Hindustan Motor, Tiruvallur. Ram is a mechanical engineer with post-graduation in production engineering from PH College of Technology and an executive MBA from IEM Bangalore. He was a research student at Nanyang Technological University, Singapore, Robotic Research Center for a few years. Ram has co-authored a book, New Sailing for Digital Transformation, with Professor L. Prasad of IIM Bangalore, published by Wiley, India, and recently the Mobility Engineer 2030 in Tamil, known as Vagana Puriyalar 2030, with Dr. Shankar Venugopal of Mahindra and Mahindra, published by Vigadan Publications in the year 2023, apart from other books and book chapters. He is a regular speaker in industry and academic forums and a blogger. He has been recognized as a LinkedIn top voice. Notably, UNIDO invited him to talk about Industry 4.0 at its 50th anniversary celebration in Vienna. With this brief introduction about the speaker and the topic, let me invite Mr. Ram to enlighten us on lifelong career in data science, AI, and physical AI. Over to Mr. Ram, please.
Thank you, Mohan sir. Thank you for the kind words. Thank you for the opportunity. It's always great to work with you. A very good evening to you, the rest of the organizing team, and all the participants. It's indeed my pleasure to talk about this topic, which is still emerging. So hopefully this should give you some ideas about what is happening in this area. So I think many of your students, many from academy, even for those professionals from the industry, this should be an interesting topic. So let me go ahead and share my screen. Okay, I hope all of you can see my screen.
Yes, sir.
Okay. Maybe I'll keep my camera off. Okay. So, sorry.
Yeah, no, still that full screen. You are.
How do I reduce this?
Yeah, you can minimize it.
I don't want to jump out of the call.
Sir, you can just drag it down towards. You cannot minimize it, sir. Yes, sir.
Okay. Fine. Yeah, looks fine now.
Okay. Okay. So the topic for today's session is lifelong career in data sciences, AI, and physical AI. So I would say two important aspects in this topic itself. One is lifelong career. So we will look at it as Mohan sir said towards the end. I will talk about lifelong learning, but I'll also give you a very interesting quote which a leading industry expert said on why lifelong career, lifelong learning is important in today's era, whatever be the industry you work in. And then I will very briefly touch upon data sciences. I will talk about enterprise AI, what is happening more from my Infosys experience. And then I will touch upon physical AI, which is a very hot topic. We will look at what very leading industry experts from Elon Musk to Jensen Huang, who's a CEO of NVIDIA, have spoken about physical AI. So it is definitely a happening area. There could be some bit of hype. There is still not full clarity on what is physical AI, what is not physical AI. But then it is definitely a topic worth exploring, whatever be your interests. So again, thanks to the organizing team for this opportunity. So like I said, it's a very hot topic. Why is there so much talk about physical AI? So here are some interesting things which some industry leaders spoke about. So this is what Elon Musk says. He says physical AI is at the heart of the master plan for Tesla. He even went on to say, so all of you must have read in the media, right? He has been promised a package of $1 trillion. So for that, he says one of the things that is really important is actually humanoid robots and physical AI. So all of us know how passionate Elon Musk is about electric vehicles, autonomous vehicles, right? Fully autonomous vehicles. But for him to say that even more important than Tesla's vehicles is the robots, the automation, the AI that is going to go into making of these vehicles. So this is one more quote he said. He said human-shaped robots or humanoids are going to be a big plan. He went on to say that these can even become more important than the actual vehicle itself because they are used to make these vehicles. So that's an interesting quote from Elon Musk. Here is what Jensen Huang said. He is also very bullish about physical AI. So all of us know about the graphic processing units that NVIDIA makes. They become a real market leader in this area. So he also feels that physical AI is going to be a big area of implementation in AI going forward. So we will look at one of the tools called Omniverse from NVIDIA, which is very popular in creating virtual environments required for physical AI. One more interesting update recently was what Jan LeCun, so he was the CTO of Meta. He is again a very respected person in AI. He recently quit Meta and he made a very interesting statement. So he said large language models are dead and physical AI is the happening place. So he is going to form his own startup focused on physical AI. He has not shared more details about it. So this is again a few weeks old data, but pretty hot from the press. And there are other companies like Hyundai and Toyota, which are also very bullish about physical AI. So Hyundai calls it software-defined innovation. So again, we will look at some industry examples on what Hyundai and Toyota are doing. Hyundai has acquired this company called Boston Dynamics. So they have a four-legged robot, which looks like a robot, which is very popular. It is used in Hyundai's factories for quality assurance and for inspection. They also have a two-legged know about the progress that this country has made in electric vehicles, autonomous vehicles, but even in automation and physical AI. But even here, there is one expert called Wang who says their educational curriculum is still not, it is still very theoretical and bookish, and it needs to get more practical so that students get hands-on experience in physical AI. So it's not just about India as a country. Even China is feeling that there is a gap between industry and academia. And then there are some more issues that have been raised. One Chinese guy said that safety is still an issue with physical AI. So I will not go into all these things, but just to give you a snapshot, people like Elon Musk and Jensen Huang, they are all talking about the potential of physical AI. At the same time, there are some concerns like this on the people side, on the technology side that need to be addressed. Okay, so what exactly is physical AI? I've been talking a lot about it. So this is an article we wrote from HFS. Like Mohan sir said initially, this is one of my topics of research in HFS currently. So this is a recent point of view that was published on the HFS website. You can go to hfsresearch.com. On my profile, you can see this. So we define physical AI as software led services. So obviously there is a software here, and it is software-led services, and these are embodied in physical systems. So today again, like Mr. Dugar, Mr. Ramesh said initially, and Mohan sir also said, when we think about AI, we think about Chat GPT, Gemini, Claude, these type of software and desktop type of tools. But when we talk about physical AI, one simple differentiation is that it is being used in physical devices. It doesn't just stop with coding or software or computers, but it is used in physical systems like robots, humanoids, autonomous vehicles, industrial equipment. Each industry has its own application of physical AI. Today we have surgical robots that can do operation. Of course, there are regulatory challenges there. If you look at Amazon, they have deployed robots which don't look like a humanoid at all, but they are deployed in their warehouses. They can help in order fulfillment to pick up parts from warehouses, from shelves, and quickly put together an order. So each industry has its own applications, manifestations of physical AI. And the other important thing is physical AI should be able to perceive, decide, and act with interoperability. So when you say perceive, you need sensors, right? It's not just about objects like we looked at the hand example where you may need to decide how much force to exert to pick up an object, and then it should decide, and that's where the autonomy comes. It should be able to act autonomously with minimal intervention. Again, one more thing we are very clear in HFS research is about human in the loop. So initially we spoke about jobs, right? So most of your students, there is always this fear about employability going down because of automation, right? So we always believe that there will be a human in the loop, but still it has to act with autonomy so that routine decisions which don't need humans are taken by these physical AI systems. Interoperability is very important when you talk about industry because there are so many devices, so many control systems from multiple suppliers. One could be from a German supplier, one could be from a Japanese supplier, but you need a central system which can talk to these two. So interoperability is very important, and all these things can operate autonomously to deliver productized services. So this is a broad definition of physical AI that we have. So I wanted to bring this up at the beginning of the session. So, like I said initially, lifelong learning in AI and physical AI, right? Why is there so much importance on lifelong learning? So this is what a Google expert, Jat Tarifi, said recently. Okay, this is not to discourage people, but he said, don't do a PhD in artificial intelligence because, as you know, a PhD is a very long process. I have been through it. I am a PhD dropout. So the world today is evolving so fast. I think I used to have a picture. I was doing my PhD in robotics. I said it is too ahead of time, and I dropped out and went back to industry. But I think now is the time when even countries like India are picking up to implement robots. So this is what this Google expert said. Basically said, don't do your PhD in AI because you initially start with a literature review. You look at what are the recent trends, what have others done, and then you pick up a topic. By the time you pick up the topic and go deep into it, already somebody would have done it. That topic would have become obsolete. So it's not to discourage people, but basically to stress upon the point that the world is changing very fast. Okay, so this is a very broad AI spectrum. So it starts with traditional AI ML. I'm sure all of you will be learning it in your colleges. I'm not going to talk about this part. Next is enterprise AI, which is where most of the action is happening. Today, all companies are talking about agentic AI, generative AI, how do they implement it. In between is what I call AI for fun. Again, many of you here are students. You don't have to wait to go to the corporate to start working on AI. I will give you some real life examples where people have really had some fun working on AI. And then entrepreneurial journey. Again, we don't want everybody to go the corporate way, but some of you may have ideas to start your own company. So that option is also very much there. And then also physical AI, which is the main topic. So very quickly, when you think of enterprise AI, these are the technologies that come to your mind: large language models, small language models specific to an industry or an enterprise, a private LLM, right? So RAG, these are technologies. When you talk about physical AI, so in enterprise AI, we talk about large language models which has been trained using text data, right? So it does pattern recognition among the most frequently used sequences of word
Sir,
to
sir,
script.
sorry to interrupt, sir.
Yeah, madam.
Can you click on that hide, sir?
Okay, okay. Yep.
Thank you, sir.
Okay. So large language models are basically trained using text and they produce output in text. But if you look at large behavioral models, these you can look at it as an equivalent for LLM for human behavior. So here it is not just about text, but it is multimodal in nature. It can take videos, it can take audios, it can take pictures, graphics, it can take 3D coordinates, forces, vectors, scalars, all that when you put together, it becomes a large behavioral model. So in enterprise AI, if you look at the tools like ChatGPT, which are implementations of large language models, physical AI will need large behavioral models. So it's not just text, but it's much more beyond that. And there is something called zero shot training, which is becoming very popular. So again, if you look at ChatGPT, Gemini, these type of tools, they're all trained using already written content available on the net. If you look at zero shot training, Toyota, for example, has something called a foundational model. They train these robots to work on specific tasks, let's say a painting robot or a welding robot or an assembly robot. So it will go through a predefined sequence of steps. So let's say a human is guiding a robot and the robot is able to train it, or you may already have libraries of such type of tasks. So when you use that to train the robot, it is called zero shot training. So the robot can very quickly be deployed on the factory. Otherwise, programming a robot is a very tedious task. So zero shot training is something that's very interesting in physical AI, which is again one of the reasons for its popularity, because it becomes very easy to train a robot or a drone or a humanoid, whatever be the object. So this is a broad spectrum of AI options that are available in front of you. So I'll very briefly touch upon the AI for fun part. So cricket is something all of us are passionate about. So I thought I will share a few examples here. So this clustering chart that you see here is one that I did a few years back. So when you think of cricket, one website that comes to your mind, at least for my generation, is cricinfo.com. I don't know in your generation, Gen Z, your students, how many of you go to this website? But it that website itself, one of the founders I had the pleasure of interviewing. But this website has an arm under it called Stats Guru, where all statistics of cricket matches are captured. What is the number of runs scored for each ball, who scored it, who was the fielder, all that is there. So all this data is available, because data is again one of the key topics for today's session, right? So with all this data, what I did was I ran a clustering algorithm. Can we cluster players? Because if you look at Gautam Gambhir's situation, right, every day morning, let's say there's going to be a one-day match with South Africa tomorrow, who is going to be the 11 players, right? It depends on the player's condition, it depends on the ground condition, it depends on the opponent's team structure, right? Are they strong in bowling, right? So whatever he picks, it's always controversial, right? So people will always say, oh, why did you pick up this person? Why did you not pick up that person? So it will be amazing if any of you can come up with a tool which does this clustering every day before a match and say this is the ideal team for the most highest probability of winning a match. So I took all the performance data of I think players and asked this. It's basically a k-means clustering. So it came up with some interesting findings. So usually we think of pure batsmen like Kohli, pure bowlers maybe like Bumrah. There are batting all-rounders, bowling all-rounders. Are there any other clustering that comes up? The clustering, as you know, is an example for unsupervised learning, right? You don't know what it is going to come up with. So all these colored dots that you see here, these are clusters of homogeneous players. You need to figure out what they are. So I won't go into too much details of it, but just to give you an idea that there are so many opportunities available for you to have fun with AI. So one more thing. So talking about Cricinfo, Professor Vishal Mishra, who is currently in Columbia University, he is one of the co-founders of this Cricinfo website. So there are others like Badri. Some of you may know him, and he's very popular on social media for those who have been following Cricinfo. So Professor Vishal Mishra also came. He graduated from IIT Bombay. So I think it was during his student days. He was one of the contributors who contributed things like natural language processing. So this link here, if you go to the video section in Infosys Knowledge Institute, you can see the interview I did with Professor Garuda Iyengar and Professor Vishal Mishra from Columbia Engineering. Columbia University itself has a very interesting data sciences institute. For those of you who are interested, they make sure that the work they do is of social good. So if you recall the AI spectrum that I spoke about, you have AI for fun, AI for enterprises, but Columbia University takes it all the way to AI for social good. So Professor Vishal Mishra used natural language processing. So if you go to the Stats Guru website and let's say you want to run a query, what is Virat Kohli's batting average against leg spinners in power play during T20s, for example, right? You need to pick up so many check boxes and parameters. Only a real expert can get the exact query that you want. So he used RAG and he used natural language processing, where you can ask in simple English the question that you want and you will get the answer. So this is an example for AI for fun. And again, if you ask me where is the physical AI part, so here is the example. So Anil Kumble, as you know, is the highest wicket taker for India, right, in Test match cricket. So he has mentored and sponsored this startup, which has basically put this sensor that you see in the picture here. It is This sensor can be stuck to a cricket bat. It can be charged wirelessly. It collects all critical information required for a batsman and feeds it to an analytics engine. And this analytics engine will basically analyze the player's performance and tell you where he or she is doing well, where are they not doing well, what more can they do to improve their batting. So this is an example for AI for fun in the cricket context, but obviously you can extend it in other areas also. So that brings me to the agenda. We started with why there is so much hype on physical AI. What do big leaders think about? What are the challenges faced? We looked at the spectrum of AI. We looked at AI for fun. Now we will get to more serious stuff. So I will very briefly touch upon data, how important data is, and then we will look at enterprise AI. What are the three major components of enterprise AI that we see? Again, this is from my Infosys experience. We will look at responsible AI. This is again very important. So again, Infosys as a company, I keep going back to it. There is an office dedicated only to responsible AI, because many clients of Infosys who are into AI approach the company and ask, are we really following practices of responsible AI? Because there is going to be a big jump in energy requirement. Some of you might have read what IBM's CEO Arvind Krishna spoke about data centers, right? He says there is so much of hype, I don't think we can really set it up. Already price of electricity is going through the roof in countries like in US, in specific cities, because it's a market driven economy, right? It's not subsidized like India there. So responsible AI is going to be very important from an energy consumption perspective, from a carbon emission, heat emission perspective. Then we will look upon physical AI and look at physical AI and complete the session with lifelong learning. Okay, so this is the agenda for the session. If any of you have any questions, please ask me. I may not be able to look at it, but I'm sure the organizing team will post it to me. I've already received some questions. I think some of it will be covered already. One question was on training part. I think deeplearning.ai is a very interesting website. Andrew Ng is one of the gurus of AI. His last name is NG, so they call him Andrew Ng. He used to be a professor in Stanford. He's a real guru in AI. So his website offers a lot of courses on AI, because Google, AWS, all of them have their own offerings, but I think that deeplearning.ai will be a good place to start. Then there were some questions on ethical AI, responsible AI. Some of that will be covered in this section on responsible AI. Okay, so this is the agenda for the session. So please stop me in case you have any question in between. Okay, so we'll start with data. So data is like raw material for manufacturing, right? To make cars and other products, you need steel, you need aluminum. Those are the raw materials. Similarly for AI, you need data. And there are a lot of analogies for data. People have called data as the new oil, because how oil is refined, crude oil is refined to create so many products and byproducts. Similarly, you need analytics to analyze raw data and come out with meaningful, actionable insights. So some people have said data is like cash. So there are companies like IRCTC which are valued based on the data that they have. Just the user interaction of how you and me book tickets on IRCTC. Do we buy food? Does it depend on the distance traveled, all that, right? So data itself is very valuable. It can be commoditized, it can be commercialized. At the same time, it can be used for controversial purposes also. So I don't know how many of you recall this controversy called Cambridge Analytica. This was a company in UK which looked at how people use social media and use that to influence people for their voting during election times. I think even in India it became a controversy, but in UK, in US, I think during Trump's first regime, there was a lot of controversy that many fence sitters, neither Democrats nor Republicans, their voting pattern was influenced by Cambridge Analytica using social media tools. So data, like any other technology, can be used for good and bad things. So Mukesh Ambani said data is like oxygen in the digital economy. So India as a country, for common citizens, we have already seen how much data is capable of doing. UPI payments, peer-to-peer payment, all that has been happening. But enterprise is where the big boom is waiting to happen. Okay, so I won't go too much into details of data in the interest of time, but now let's look at enterprise AI. Right? So these are the three broad areas. Again, in my earlier role, I moved out of Infosys in September. So there was this team called Infosys Knowledge Institute. If you go to infosys.com/IKI, you can see all these things that are publicly available. So this was Nandan's idea to have a thought leadership focused team within Infosys. So I used to lead engineering and manufacturing. We used to do a lot of research, work with our colleagues within Infosys and publish it. So these are the broad areas. So it starts with AI readiness, because like all technologies, once the technology becomes popular, every CIO wants to jump in and say, I am also working on this, right? There's this FOMO effect, fear of missing out. So we did some studies on how ready companies are before they can really start doing AI, because it is not just the technology part. I will show you the 5 other dimensions of AI that are required for any organization to be successful. Because for those of you who have spent a lot of time in the industry, there are many waves of technologies which have come and gone, and many millions or billions of dollars have gone down the drain. If you take my own example, product lifecycle management, or PLM, is one area where I have worked extensively in General Electric in their energy and aviation business. Many waves of this PLM implementation just went away because the engineers were not ready to adopt it. So change management is a big issue. So we will look at all those aspects when we talk about AI readiness. We will look at data also. Data is also an important part. And then we will look at the responsible AI, because as you know, AI has many issues like hallucination, bias. I'll give you some real life examples where corporates have faced some embarrassing situation because of ethical issues, because of bias. And then we will look at business value from AI. So all this is fine. The technology may be very good, but where companies face big issues is to get return on investment from the money that they are spending on AI. So just like the Satya Nadella example, right? It can't be just productivity, but it has to be more. So I will share examples of which type of industries, which type of roles have got a return on investment from their AI investments. So talking about AI readiness, this used to be a very popular cartoon that was circulated on WhatsApp and social media. So basically, it's a funny part, but basically what it says is that many CIOs, CXOs, chief digital officers, we even have chief AI officers, all those people, they want to implement AI right now because of peer pressure, maybe pressure from their management on their board, but they don't know exactly how to make progress. So any insights that we can provide on do's and don'ts, how to implement, how not to implement, will still be very, very valuable for the enterprises. So now let's look at the readiness framework. So like I said initially, it's not just about the technology. The technology may be mature. So if you look at these 5 pillars here, technology is there on the top left, right? Technology is about the infrastructure, the security, the APIs. That is all there. But the other things that are equally important, one is strategy, for example. So big technology like AI cannot be implemented just for the sake of it. It cannot be a pet project for the CIO or the CDO or CEO or anybody. It has to be aligned to the company's overall strategy or business objective, which is about growing their top line. They may want to sell some products or services. So this AI implementation has to be very well aligned with the corporate strategy. And then you need governance in place, because one more issue in tools like ChatGPT is that sometimes confidential information may be given away just by the prompt that you use. So people need to be trained. Sometimes hallucination is a big issue. So I'm sure most of you would have read in media, Deloitte faced some embarrassing situations. They submitted a report to Australian government. It had some cases of past examples. Those cases did not exist at all. It had completely hallucinated it, and Deloitte ended up paying a big fine for the Australian government. There were another 1 or 2 examples in Deloitte itself. So governance is very important, to put guardrails around this AI implementations and make sure you do checks and balances for hallucination. Talent is a human part. Data, again, like I said, is the raw material. So only when these 5 things are there together, your AI implementation will be successful. So these are the numbers from the Infosys Knowledge Institute study. From a strategy perspective, only 15% of companies were ready. Governance 10%, talent 20, data 10. So talent again is very interesting. We think people is the issue, but it's slightly ahead. But one issue people face, enterprises face, is there is a difference in the velocity gap. So people like you and me, thanks to internet and other media today, we are very well aware of what AI is capable of doing. Could be DALI for images, could be Chat GPT or any other tool. But enterprise leaders struggle to adopt the same for their company, because just employees using AI will not be sufficient for them. It has to translate into meaningful business outcomes for them. So there is what is called a velocity gap between individuals and corporates when it comes to the talent side. So anyway, technology is most advanced, as you can see here. So when you put all these five together, which are how many companies are good in adopting all of them together? This is a very low number, 2%. This is a little outdated, maybe 6 months to 1 year. It must have definitely improved, but I'm pretty sure it must be in single digit. Not all companies have got all these five aspects together. So companies are fully ready for AI only when they think about all these five and when they're ahead and they have a plan in place from all five perspectives. So that's on AI readiness. So now let's come to responsible AI. So responsible AI is not just about ethical AI. So here are some broad tenets of responsible AI. First, obviously, it has to be ethical, which means it should not discriminate against people based on their gender, based on their race, based on their ethnicity or citizenship, all that. So that is ethical AI. Explainable AI is very important, because if you look at AI tools like a simple neural network, right, it is basically like a black box. It has been trained using historical information. And then if you give a new data set to it, it will take a decision and tell you either a go, no go, or any classification that it does. So if that person who is impacted by it wants to know on what basis was I classified this way, right? Could be a loan application. Maybe the loan is rejected. So you will have to go back and explain what are the parameters because of which a particular application was rejected. So explainability is becoming very important in specific applications like banking or education sector or even recruitment, if AI is used as a tool to filter people. Social good is the Columbia University type of universities, right? Any proposal that you take to the board for AI implementation, they will ask you, is there a social good? It is beyond just being responsible, beyond just looking at the energy consumption or the carbon emission. Is there a social good that's possible? So that's how seriously some organizations take AI implementation. And then it has to be green. So here are some examples where companies did not follow it and faced an embarrassing situation. If you look at ethical AI, Amazon's tool, this was much before ChatGPT, all these tools became popular, because traditional AI ML, as you know, has been around for decades. So universities like Stanford and MIT have been doing amazing work. Not just them, even in India, many universities have been doing work. But if you look at this Amazon example, so there was a hiring tool which they used. It was obviously trained using historical data. Many humans had filtered through resumes and decided whom to shortlist for an interview. So that data was used to train this tool. And when this tool was deployed for live candidates, what they realized was that it had a bias towards male candidates. So many women candidates were not called for interview. Obviously, it was because of the inherent bias. It could not be intentional, but it was spotted. So it became very embarrassing for Amazon and they had to scrap this tool. But now there is much more awareness. So this again is a slightly outdated example, but it explains the situation well. Explainable AI, like I said, what is the reason for rejection of an application? Could be a bank loan, could be admission to a university. These are situations where explainability is very important. Being green, again, the next slide I will show more examples, because the energy consumption required for running AI tools, your data centers, your large language models, this is really going through the roof. There are many experts who are worried about this. So you need to keep the green perspective in mind, and then social good. Plus, these are other very basic examples of responsibility. You need to respect people's privacy. You need to make sure there is safety, reliability. So you must have seen the recent outages that happened in Cloudflare. So ChatGPT went down. Reliability is very important. It is okay for common people to use it, but if then uptime is very important. So reliability is something very important. Regulatory compliance also varies from country to country. Countries are really struggling today. So you must have read again, Australia is going to ban usage of social media for minor students. Countries are coming up with their own ways on how to manage this beast, because there are positive things at the same time there are negative things. So regulatory compliance is something very important, which will vary from country to country. So here is one interesting on usage of energy by AI. So Google says one Gemini prompt. We may think it is just a prompt that I'm running, right? But that is equivalent to running a microwave for 1 second, or it is also equivalent to 5 drops of water used for cooling. So we may think it is just a simple prompt or a query from outside, but this is how much of energy consumption and cooling it translates to on the data center. Again, we need to be very responsible in how we use uh, tools like ChatGPT. This was another interesting interview I had with Professor Ramesh Ramurthy, currently in Rice University. He's from the University of California, Berkeley. So even before all these technologies became popular, he made a very interesting hypothesis. He said by 2030, 25% of global energy will go into electronics. So if you just put that in perspective, today, if you look at US, the biggest consumers of energy are transportation, industry. Nobody thought of data centers, but today with emergence of ChatGPT and all these large language models, the energy requirement for data centers is growing very rapidly. So this can become a reality. So when he says electronics, it is your data centers, it is your IoT, your sensors, laptops, PCs, smartphones, all that you use. The total energy produced, 25% of it could go for all these electronic devices. So that's a very strong statement. So we need to be responsible. So you're all, many of your future leaders. So you need to keep this in mind. Even the data center that was set up in India, right, in Andhra. So that became a very controversial thing. Are we going to have enough energy to keep it running? Do we have enough water to keep it cool? There is a lot of research going on only on the technology that is used to keep these data centers cool. So again, this video is available on the Infosys Knowledge Institute video section. For those who are interested, please do go ahead and see it. Jeff Bezos again did a very interesting prediction. He says in the next 10 or 20 years, we could have data centers in outer space, because there you don't have to worry about cooling. Outer space is already cool. And if you use solar panels there with sunlight, we can power these data centers. So given how much of a visionary he is, so we never know, this may even happen. We may have some low orbit data centers who are circling the earth from where we use data. Okay, so we looked at what is explainably, we looked at the readiness first, and then we looked at tenets of responsible AI. Now coming to business value from AI. So this is the ROI part. This is again from the Infosys studies that we did. We looked at different functions and different industries to see who are the ones who are deriving most value from AI. So if you look at a functional perspective, from a use case perspective, no surprise. So software development is the biggest use case where companies have realized most value from AI adoption. So it could be software development, IT operations, facilities management, cybersecurity, technologies like vibe programming, vibe coding, where you just say what is your requirement in English and it will give you the codes in whatever language you want. Of course, it is not foolproof. Testing becomes very, very important, but this is the function, so to speak, where AI has been used the most and most value has been derived. Next has been marketing and sales. Again, a lot of interesting use cases here where marketing content, creativity is all generated using AI. So generative AI has been very popular in the marketing function. And if you look at it from an industry perspective, white collar industries like banks, professional services, high tech, these are the ones which have used most of AI and derived value from it. But if you look at blue collar industries down below at the bottom of the chart, like automotive, manufacturing, public sector, electricity, these are the ones which have not seen much implementation of AI yet. So that's where physical AI comes. There is so much of potential. A lot of automation has happened. At the same time, automation again is fraught with many risks. So that's where we look at physical AI, which can help reduce the risk of implementing industrial automation. Okay, so that is about the business value from AI. So very broadly, I spoke about three things under enterprise AI. We looked at AI readiness. So that will give you an idea about how it's not just the technology, the APIs or the RAG. You need to look at the strategy perspective, the governance perspective, people part, the data part, because many companies use synthetic data to run their AI tools. So getting clean data that is complete and is itself a big challenge in AI implementation. So AI readiness should be something kept in mind. Responsible AI is a big topic. Like I said, Infosys has its own responsible AI, not only for its own operations, but also as a client-facing team to offer services and consulting in responsible AI itself. And then we looked at business value from AI. Okay, so that's a very holistic 360-degree perspective on enterprise AI. So just to summarize it, what works in AI? So this is again from the Infosys Knowledge Institute findings. So AI works when data is shared. That's a networking effect. Could be an automobile company which shares data with its tier one suppliers. Could be with its downstream dealers and retailers. Trust is very important in AI, and AI is very multidisciplinary. You cannot just have experts. So later in the last section, I will talk about the T-shape model. One of the questions was how can I excel in AI? So what I would say is, instead of looking at it as a technology, those of you who are students, early career professionals, you need to pick up a particular domain expertise. So that's where being multidisciplinary helps to make sure AI projects are successful, because again, I keep talking about it. It's not just a technology, the domain knowledge, whether it is insurance, banking, healthcare, manufacturing, that's going to be very important. Okay, now we come to the physical AI part of it. So again, please stop me if there are any questions. Okay, so here are some interesting names who are doing the rounds in physical AI. One company, like I said, is Boston Dynamics. So Hyundai acquired this company. Boston Dynamics is an American company, but Hyundai bought it. In robotics itself, there have been some very interesting acquisitions. There was this company called KUKA Robotics, which is a German company, very popular for those of you who are familiar with robotics. But Media is one household appliances manufacturing company in China, which bought KUKA Robotics. ABB recently sold its robotics division. Boston Dynamics has been acquired by Hyundai. So that itself shows you how much importance these trusted manufacturing companies place on physical AI. So coming back to Hyundai or Boston Dynamics, I mentioned at the beginning of this session. So this Spot is a quadruped robot, the blue colored dog that you see here, right, standing next to the lady. So this four-legged robot has been very popular in industries. I've been working with a lot of IT companies like Wipro, HCL, Cognizant, TCS, Infosys. All of them have this robot which they've used for different applications. It's called Spot. It's a very popular one. It uses computer vision for quality and safety inspection. So the Singapore electric vehicle factory that I mentioned at the start, this robot has been deployed there. So it goes around looking for safety and quality issues. That could be a scratch on a car which a human would not have noticed, or maybe there is a dangerous situation. There is some tool protruding which can hit somebody, so it will alert. So this mobile robot has been very popular in Hyundai. And then if you look at the humanoid part, Atlas is again the popular brand name from Boston Dynamics. Here, large behavioral models have been adopted for this robot. These are not very mature yet. These are still proof of concept, small scale implementations, but again, very interesting for you who are looking at topics of research. So physical AI is going to be a very important one for different industries. There are different manifestations. Here we are looking at four-legged robots, two-legged robots. There could be drones. There are autonomous guided vehicles inside warehouses or factories. Many such interesting manifestations of physical AI are coming up. So here are some more names. So Siemens is again very deep into physical AI. So as you know, software-defined products are a very core foundation for physical AI. Because if you want to send some instructions to a car or a microwave or whatever be the product, it should be capable of accepting those commands and it should be able to give a feedback. So which means it should have a controller, it should have IoT to give feedback. In very simple words, all these products need to be software defined products. So software defined products are pretty popular in automotive industry, right? Software defined vehicles have become very popular. You know, those 5 levels of autonomy which Society of Automotive Engineers has defined. So level 2, level 3 is very popular. You have ADAS systems. So Siemens has signed up an agreement with Accenture to work specifically on software defined products. One more thing you will notice is there is a lot of partnership that is going on. So here in this case, Siemens has partnered with NVIDIA. NVIDIA's Omniverse is a tool that's very popular in the industry. So both of them together have implemented this physical AI for a battery manufacturing plant in US. So even before the actual factory was set up, they created a virtual replica of this factory, and you can simulate different scenarios. So this is a little more advanced than just a digital twin. So digital twins became very popular to create a virtual replica of physical things which are already implemented. But here, even before you have an actual factory, you can simulate it. Are there any bottlenecks? Will your production get stuck somewhere? All those things can be created using Omniverse. So you create a 3D replica of your factory which is not even built. You can play around with the layout. You can optimize the layout for the workflow. So Siemens has partnered with NVIDIA to do this interesting implementation for this Freyr battery manufacturing gigafactory in US. And here's a very interesting observation which Elon Musk said. So if you know the EV factory that they have set up in California, right? So it had a lot of teething trouble. So he himself admitted that it was probably because of excessive automation. There were too many robots. So obviously physical AI was not very popular as a concept when this factory was set up. So maybe going forward, even before once you have a plant layout that is put on paper, you're going to have a CAD model for it, but we are not going to stop just with 2D, but we are going to create a 3D virtual replica of this factory. And it's not just static, you can actually make it very dynamic with all the equipment, the robots, the products that you're going to manufacture. Today, computation has become much more affordable, so it is going to be easy for you to create a virtual replica of a factory before even the first brick is laid for the foundation of the factory. So here are the levels of physical AI. Again, this is from our publications in HFS research. 3 very basic levels. You can call them as assisted physical AI, conditional physical AI, and fully autonomous physical AI. Assisted physical AI is where you use a human to program a robot for a specific task. Humans are always available next to handle any exceptions. AI can be used for offline programming. So real physical AI is where it is deployed on the edge, right? If you're going to let a robot to talk to an algorithm on the cloud for making a decision making, it'll be too late. It could be a safety issue. It could be a very critical issue on the shop floor. So ideally, the physical AI is where it is deployed on the edge on the device itself. But when you talk of assisted physical AI, some AI could be used for offline programming where you can simulate scenarios to decide what is the optimal path for a robot for an assembly with avoiding singularity, avoiding any collisions with humans, right? So that is assisted physical AI. Then you have conditional physical AI where sensors can be used to take autonomous decisions. So here cobots have become very popular. So earlier, if any of you have been to automobile factories, all these welding, painting robots, they're all implemented within a cage because there is a very high potential that a robot may cause some impact. It may collide with a human. But today we have what is called cobots or collaborative robots. You have robots working along with humans as a colleague. So such robots have a lot of sensors. So even a small touch, if a human comes near it, it will sense and it will immediately stop its motion so that there is no collision with a human. So here there is more deployment of edge-based AI for local decision making. There are companies like BMW who have used conditional physical AI successfully. And then the highest level of physical AI is autonomous physical AI, where we have a fusion of multimodal sensors. So if you take autonomous vehicles, for example, so there are 2 very broad schools of thought, right? So Elon Musk has been saying that computer vision is the best technology for sensing for autonomous vehicles. But as you know, it has its own limitations. It may not work well when it is dark in certain environmental conditions. Computer vision may not work. The other school of thought is using lidar or lasers, right? Lasers, of course, 3D lasers, lidars have also come up now. They also have their own limitations. But today, most leading companies do what is called fusion of multimodal sensors. So you can take a lidar, a radar, ultrasound, whatever sensors you have, plus computer vision. You can combine all these inputs to take a decision, whether it's an autonomous vehicle moving on a road. So if autonomous trucks are waiting to be deployed. So Daimler is a leader in this area. So I had an opportunity to interview one of their leaders. That article should be published soon. I will share my details if any of you are interested in these topics. So you can definitely follow them. So automotive is one industry where they may not call it physical AI. It is called by different terms. It's called ADAS. There now there is progress from level 2, 2.5 to level 3 of autonomy. But very generically speaking, these are the three levels of physical AI that we see happening in the industry. And if you look at the value chain, it is not just to be used in factories. Generally, we associate physical AI only for factories, robots that are used in a shop floor. But if you look at it from the left side of the spectrum to right, starting with factories. So in factories, you can implement what is called a smart factory. It is connected. It is connected to the office equipment. The MES system is connected to the ERP. We call it IT/OT integration. It is used for material movement in factories. So that's where, as you move towards the right in the value chain, you have factories. Factories need materials to work. For those materials, you need transportation, mobility. That's where physical AI is used in terms of smart mobility with autonomous vehicles, autonomous material movement vehicles, drones, all that is used. And then industrial equipment, which are used for the actual tasks. So you have a factory, you have the material to do it. Now you need industrial equipment for value add. It could be a CNC lathe, it could be a robot. There also physical AI is used. And even in home appliances. So this is not just in factories, but today you have home or kitchen appliances, could be a washing machine, could be a, a, a mixer or any kitchen appliance. Even those appliances are connected. So again, we need to be careful there. I'll give you an example where an air fryer actually started spying on its users. It was okay to it was ready to take voice commands, but it started listening to conversations to which it should not have listened at all. So cyber security is very important there. So this is a value chain of physical AI. Here are what a few more respect like World Economic Forum or Federation of Robotics have spoken about. AI. If you look at the International Federation of Robotics, this is a not-for-profit organization that closely follows trends in robotics. So they publish metrics like what is the density of robots. So I was talking to Mohan sir yesterday. So South Korea is the country with the highest density of robots. So IFR publishes the number of industrial robots that are used for every 10,000 employees in factories. So China is catching up, but traditionally, for those of you who have been observing robotics, South Korea is the country with the highest density of robots. So International Federation of Robots, in its publication on what are the top 5 global robotics trends in 2024, said AI and machine learning is the biggest trend. So again, it has been used for so many decades for offline programming, but when the AI gets embedded in a device, in an equipment like a robot, it becomes physical AI. So this is one of the big trends to watch out. Also, World Economic Forum, again, a very respected organization. This organization in Germany coined this term called Industry 4.0, right? The fourth industrial revolution. So what they said is that physical AI is going to power the next big wave in industrial operations. So I've given this Toyota example also. Toyota is one company which is forming what is called this robotics foundational model, which is basically a library of large language models. This can be a large behavioral model using pixels, 3D coordinates, vectors, forces, kinematics, dynamics. When you put all that together for a robot, it becomes a large behavioral model, and it can be used for what is called zero shot training. In World Economic Forum also spoke about this zero shot training. So this slide I will quickly skip through it. So this is basically about the automotive industry and how it is happening. So if you look at auto industry, traditionally they have had a waterfall model for new vehicle development, but software, as you know, is follows agile practices, right? So there is a big mismatch between these two. All models, as you know, go step by step. It can take a few months to even a years. So it takes about 5 to 7 years for a new automobile to be rolled out. But automobiles are increasingly become software defined vehicles. It is very easy to send an upgrade just over the air, right? So many cases we see where Tesla or other companies have had software issues. They just send it over there. You don't even need to take it to a dealer shop. So the issue companies face here is this mismatch in the velocity between the hardware cycle and the software cycle. So there is this model called this V model where companies are trying to integrate the software and the hardware development part. I will not go into the details of it. So this is the air fryer example which I was giving you in UK. So this was supposed to, it had the feature where it could take voice commands for its operation, but then it started listening to what its owners were talking beyond its instructions, and it started sending all this voice data to its manufacturer. So that was a big no-no from a privacy and cyber security perspective. There are some more cyber security examples where these connected products or products with AI have crossed the line. So that was on physical AI. So again, I'll take a small pause here. I think I covered a lot of topics. If there are any questions, please feel free to ask. I think we have another 10 or 15 minutes. In the last part, I will talk about neo skilling for lifelong learning. Okay, so if there are no other questions, I will quickly go ahead to this section. So this sometime in 2018 or 2019. Even then, before ChatGPT, already this digital technologies had started proliferating, and there was this fear of it. So everybody was aware that people had to be reskilled because experienced employees, whatever be the industry, they have this tacit knowledge, right, which an AI or a robot or an algorithm can never find out or duplicate. So reskilling became a very important topic. But then who will fund it? Will it be from the government? Will corporates fund it, or should individuals only pay from their pocket? Today you have NPTEL, MOOCs, so many MOOCs platforms like edX, Coursera are all there, right? You or me can go ahead and enroll for any course and do it at a very low cost or even free. So that's when I thought about this reskilling, and so I worked with Professor Prasad. We came up with this term called neo skilling, where we said successful business leaders will look at futuristic skill sets, not just today's skill sets. So today, if you see prompt engineering is still evolving, there is even context engineering, where you need to keep the memory of previous prompts, right? So that is a context part. So that's one example for neo skilling. So we came up with this continuum of skill development, starting from very basic skilling. Skilling is what we all undergo in universities, and then after you come to corporate, you may pick up a new skill set. That's just a delta, a small incremental improvement. Reskilling is when you completely move into a new area. So today, AI is used in what we call service as software. Procurement, for example, these like Walmart have successfully deployed agentic AI for procurement. So let's say it has to negotiate with somebody to buy some not very critical material, could be some toilet paper or some consumables like a coolant used in a factory. So you set the requirements for it. This is the quality of paper. This is the maximum limit to which you can go. This is a minimum. The other person may not even know that they are negotiating with a software agent. So that's how much technology has progressed today. So such shifts are called reskilling. And neo skilling, even physical AI could be one example. So I don't think many companies today are ready for this concepts like zero shot training. So successful companies like Hyundai, they're already talking about it. Only very little information has come out in public. So that's where these could be opportunities for you. So this is a book we wrote called Neo Skilling for Digital Transformation. So it continues to be relevant because, again, like I said, this book was written before GPT and Gemini, Claude, all these tools became popular. But technology, thanks to Moore's law, and now we have even more bigger topics like quantum computing that are coming up. So it's very important. Our educational curriculum cannot always play catch up with the rate at which the industry is moving. So that's where sessions like this, going to conferences, meeting people, your spending time in industry during your internships, they are all very important for students. Okay, so these are the new career paths that you have today. So we talk about neo skilling from a student perspective. You may say, why should I worry about it? But look at the plethora of new career paths that are available for you. Traditionally, if you look at it, after graduation, you may have these 4 or 5 branches, right? Some of you may go for your PG studies. Some of you may go into corporates, public sector, could be even entrepreneurship. Within that also you have branches. But if you look at these yellow boxes here, today you look at there are new roles called professor of practice which are coming up. You can be from the industry, but you can still teach in academia, because universities are realizing that this industry knowledge is very important. So people who can play both roles are called a professor of practice. You have data scientist, prompt engineer. You have fellowships offered even by government of India for AI. Today we are looking at what is the quantum strategy for India. Semicon has become a very hot topic because we want to be self-sustaining in semicon. We can't be dependent on China or TSMC in Taiwan. So sovereignty is from a hardware perspective. So that's where even government of India is taking it seriously. So they keep publishing these openings called fellowships, where you go spend 2 3 years and you help the policy makers to decide what our country should do. Even at state level, there are industry 4.0 study for Tamil Nadu manufacturing. And then even entrepreneurship. So you don't necessarily have to start your own company, but even large corporates give you an opportunity where you are given the freedom to start your own small company without quitting the company or the job. Okay, so this is the T-shaped learning model. So people obviously are a very important part in this AI journey, but it is not just a technology. This is where all the technologies, AI, ML, generative AI, RAG, NLP. But just knowing these technologies is not enough. You need this vertical focus or depth. So that's where the industry perspective comes, because there is a lot of tacit knowledge which cannot be explained. Only somebody who has worked on a shop floor or in a hospital or in a retail store will know the nuances of that industry. So it's very important to have a T-shaped career. So for those of you who are students, pick up any industry that you like. You may want to try different things, but you will realize that a particular industry is of importance for you. So when you always couple your AI knowledge with an industry, it becomes much more valuable. We'll also look at what is called the ikigai, or the purpose of life. So all these things basically are to help you to have a successful career in AI. I'll quickly skip this slide. If you look at what ails education, so education, like I said, always plays catch up, not just in India, but you saw the China example also. So the answer is in ail itself. So we need to have what is called active learning. So just listening to lectures is not sufficient. We need to take our lab sessions seriously. Generally, if you look at India, we give secondary importance to our lab sessions, but it'll be so much interesting if we give more importance to labs. So our learning doesn't stop with classes. And then intentional learning. So again, it's not just classes and labs, but a session like this, attending a conference, meeting business leaders, doing internships, factory visits. They are all intentional learning. And then lifelong learning and skill-based learning. So again, many companies today, and again, not to discourage you, but they don't really need a formal degree to take you up for employment. If you can demonstrate the skills, so that's where doing projects, writing about it, blogs, speaking, podcasts, they are all very important to get visibility. So we are moving towards a more skill-based world where formal degrees will have only limited importance. They are still important for an entry, but you need to make sure you can demonstrate skills in all these areas. Yeah, I'll quickly skip these slides. From an MBA perspective, many universities are thinking like Harvard and Yale. World is changing so fast, but they can't keep spoon feeding their students all the time. So they are thinking of making an MBA program, and then make sure their students come back every 1 week in a year, either physically or virtually, to pick up new concepts. So education industry itself is holding a mirror and seeing how they can help their students practice lifelong learning. Okay, so towards the end, as again as students, it may be very confusing, so many things happening around you. So how do you decide where to take your career? So that's where this Japanese concept called ikigai may be very interesting for you. So the first part is, think about it, introspect. What is it that you really like doing? Some of you may like coding in Python, for example. And then, are you really good at doing it? So maybe you may go for a hackathon, or you may participate in some competition. You can realize whether you are really good at doing it or not. Because some things you may like doing, but you may not be good at doing it. And then what does the world need? So in campus placement, are you going to get a job for this skill set? Is it going to have a good pay? Are there enough openings? So if you look at the intersection of these three things, what you like doing, what you are good at doing, and for which you're going to get a good employment opportunity with a good pay, the intersection of these three is what is called a sweet spot or the ikigai. So if you discover this, then like they say, right, once you start liking your job, it's not a job anymore. It's more like a hobby. You don't get up every morning and say, oh, I need to go to office. You're going to enjoy doing your job. So for those of you who discover physical AI as your ikigai, there are opportunities for you. So I spoke about different concepts. So try it out. Think whether you really like doing it. Get your hands dirty. Test it out whether you are really good at doing it. How good are you? How can you improve it? Again, not to discourage you. It's not to say if you're not good, drop out of it, but see how you can improve it. Because again, there are so many opportunities to learn, like the MOOCs courses that are available. Most universities, even in India, right, NPTEL itself is a big ocean of knowledge. So you can very easily enroll for those courses and improve your level of understanding if you feel you're not good enough. Okay, so I'll skip this slide. So this is my last slide. So this is my profile on LinkedIn. So like Mohan sir said initially, so I keep writing, talking about this topic. So in HFS research, in Infosys Knowledge Institute also we used to do it. Now I do it from HFS perspective. So I keep looking at what is happening in the industry. There is a newsletter that I do on LinkedIn about these trends, plus research publications from HFS research right now, based on my interactions with industry leaders and IT leaders. So I keep talking or writing and publishing about this on LinkedIn. So for those of you who feel this topic is of interest, so please do follow me. Happy to stay in touch with you virtually on LinkedIn. So with that, I will stop my session. I have a hard stop at 8 o'clock, but we have another 5-10 minutes if questions. Thank you so much for the opportunity.
Thank you, sir. Thank you for your wonderful session. So there are no questions as of now in the chat box. So I just post most of the questions that has been given during the registration you have answered. So I'm just having some couple of questions that will be more. You can just give more on that. So that I'm just asking it. What are some or AI that you believe need to be corrected, and how do you see the future collaboration between humans and physical AI systems evolving in workspace? So you just talk about the thing only, the second systems evolving in workspace. So you just talk about the thing only, the second question only, you just talk about the entire session. Can you just throw?
I think the misconceptions.
Yes, sir.
So one misconception specifically among students is they think if they are good in technology, then they can excel in that field. So again, I spoke about it in that slide on AI readiness. So it's not just about the technology. So strategy may be too much now, but after the student do their MBA, they may get an exposure to strategy. Important is to think about the people part. So change management is again something very important, because all these technologies are basically about digital transformation. They are going to change the transformation. They are going to change the way a person is going to work, whether it's in a hospital or a retail store or a factory. So as future leaders, how can you convince your people? You're only going to make it easy for them to do that. 5 factors beyond just the technology. So one misconception is that if the technology is good enough, it is going to be adopted, but that is not the case. So in case of AI, you need data, you need governance mechanisms to make sure you don't put your company in a tight spot. You need strategy to get return on investment from your impact under so much stress, right? Visa problem with people is what is called a change management. That these are the other challenges. Then
And incorporation of ethical code at the structural base by law and challenges to its effective implementation.
yeah, I think that so ethical AI is one of the tenets of.
Yeah, am I audible to you?